Let's go over a practice problem for this week's discussion quiz. And it says to differentiate this implicitly defined equation. So that is to use implicit differentiation. When we're done, we'll solve that for y prime, which is the same thing as dy dx in this case. So if I look at this equation, I'm going to differentiate both sides with respect to x. And I'm going to go through term by term to do this. So I'll start with y. What is the derivative of y with respect to x? It is simply y prime. Then you subtract off the derivative of e to the xy. This is a composition of two functions, which means I'll have to use the chain rule. To start with, the derivative of e to something is e to that thing. So it kind of starts out simple. You get e to the xy. But by the chain rule, you have to multiply by the derivative of what's composed in the function. So this next part I'm going to do here is to simply multiply by the derivative of just this part here, the derivative of xy. Because I have to use the product rule, I'm going to introduce some parentheses. So starting with the first term, I'm going to take the derivative of x with respect to x, that's equal to 1, and I simply multiply that by y. To this, I add x, so the first thing alone, and then take the derivative of the second piece. What is the derivative of y? Well, it's simply the derivative of y. I've differentiated the left side of this equation with respect to x. On the right side, I'm going to go through term by term and take the derivative starting with 5x cubed. So since this is just x, I'll bring the 3 down front. 5 times 3 is 15 times x to the power of 2. To this, we're going to add on the derivative of y squared. So I still use the power rule. The 2 comes down front, and you copy down the y, so you get 2y. You would subtract 1 from the exponent, which would make this a 1. I'm going to choose not to write it. But by the chain rule, you have to multiply by y prime. This came from the fact that you have to take the derivative of y with respect to x by the chain rule, and that's why this goes here. The calculus portion of this problem is done. The rest is simply solving this equation for y prime. And I see there's one here and there's one here. My approach is going to be to move all of those to the left side of the equation. Anything that does not have y prime, I'll put on the right side of the equation. So I think I'll start this by multiplying this negative e to the xy into the parentheses. I'm also going to order things in a more simple way. So I have y prime here. I'm going to copy that down. We have y prime. When you distribute in e to the xy, it gets multiplied here. I'm going to write this as simply y times e to the xy. Next, I distribute this here. I'm going to write this as minus x e to the xy times y prime. There isn't really anything to simplify on the other side of the equation. I'll just put 15x squared and then plus 2y prime. Okay, what I'll do next is leave this term and this term on the left, but I'm going to add this to the other side of the equation. At the same time, I'm going to subtract this from both sides, and I'll write that here. So this gets added over here, this gets subtracted over here. In doing that, we have y prime. I'm subtracting 2y prime from both sides, and I'm leaving the minus x e to the xy y prime by itself. On the other side of the equation, we get 15x squared, but since we've added this to the other side of the equation, I'm going to put that right here and call it plus y e to the xy. All right, here, each term has a y prime. I'm going to factor it out. I'll have 1 minus 2y and minus x e to the xy left over. So this is y prime times 1 minus 2y minus x e to the xy. And on the other side of my equation, I still have 15x squared plus y e to the xy. The final step to solve for y prime is to divide this to the other side. So I'll simply state my final answer now. Y prime is equal to, this will be my numerator, and this will be my denominator. So that is, we have 15x squared plus y e to the xy, all divided by 1 minus 2y minus x e to the xy. This is the final answer for the problem. We not only took the derivative, but we solved for y prime, and that's the final answer.